So I hope everyone can hear me. Yeah. So yeah, welcome to our Gemalto session on what we can do with Java in the embedded space. And I guess some of you already saw me this morning. So today in my session now, we'll give you a little bit more detail about what we've been doing with Java and embedded and what we've been doing in embedded. And in the second half of the presentation, my colleague Markus, who's from our local office here in Stockholm, we'll go a bit more into the technical specification of our new product. And we've brought a little demo, nothing too fancy, but we'll show it live and you can see sort of a first small hello world type of application, but embedded in cellular. Okay, so I was a bit surprised at how many people actually know Gemalto. Gemalto's addressing a very large potential in today's connected digital world, where you've got already more than 6 billion mobile subscribers. You've got 2 billion internet users. And what is particularly interesting to us, and one of the reasons Gemalto went into the M2M space, and now Oracle's looking at this, is the 50 billion potentially connected devices that are out there. And last year, I don't know who went to Java One on Open World in San Francisco. There was a guy from ARM who mentioned 1 trillion connected devices. And I think this is great news, because if I work in a company where only today 1 billion devices are connected and in the future 1 trillion devices are connected, then I'll probably be in the right place to earn $1 million that Henrik was referring to earlier. So anyway, what Gemalto does in this area, this huge connected space that we're going to have, is that we address some of the issues that we see. So there's a lack of security. Gemalto is well known for security solutions in the SIM card and the banking business, IDs. We actually delivered the solution to the White House, the access control. What we see is that services are hard to use, and support costs are typically something that most companies worry about. And in our endeavor in M2M as well, we want to make this technology more easy and more simpler to use and to keep your costs down. And we believe that Java is one of the solutions that will help address this issue of complexity, reduce the complexity, take it out, make it easier for our customers to use embed cellular into any type of solution. And this is one of the reasons we're working together with Oracle. So yeah, if you look around the world around us, there's connectivity that can go into anything. And Henrik already gave an overview this morning. So if you look around the world here, you can have connectivity and logistics. We've got customers that are putting this into e-mobility for charging the vehicles. You've got e-call, you've got these days intelligent vending machines. People are trying to analyze who's walking past the machine. Is he male, is he female, adult, child? Try and optimize the display a little bit and the way the goods are presented. You've got, like we show in the corner of the building there, security solutions that are getting connected to cellular as well. Not only the video cameras, but a very large customer of ours is Honeywell in the US. That sells home alarm systems, very simple to install. You don't have to do any fancy connectivity connections. Just put it up in the home. It's connected to the outside world. Yeah, and then energy, a very big topic, and we were hugely successful in the Nordics actually when we deployed how many? 800,000 smart meters, not particularly smart yet. All they were doing was sending the data. So we've got some brilliant minds in here that are thinking of more intelligent things to do with a smart meter than just send the pure data reading over the internet or the cellular networks to some back office. So what do we do? Forgot about that. So as you can see, it's all around us. You can go and put it into anything. If we look at what we do, our customers are taking these modules, so they come in various sizes depending on their capabilities. The small one here, this is the one with Java on it and running on 3G. And what we do with our solutions is that we've taken the cellular technology from people like Qualcomm, Intel acquired Infineon, the mobile communications unit, and we take their basic technology, we put it into a ready-to-use and simple form factor. So we add some of the high-frequency power amplifiers, filters, and stuff, and we package that into a stable form factor that is simple and easy to use. Stable is important because a lot of our customers, they want to be able to build a meter, smart meter, for example, today, and they want to be building the same thing in the same form without having to do a redesign in 3 years' time. So having something that remains stable and they don't have to adjust the application in the past was always very important with respect to the physical design, the interfaces, the layout of the PCB board. But what we've seen from our customers, the ones that are using Java, is that not only is the physical form factor stable, but also the software, they can easily port it from one generation to the next generation. So this is where we see Java adding stability, not in the physical sense, but also on the software layer. And by packaging this into a ready and easy-to-use form factor, we're helping basically anyone embed cellular into their product and make it mobile. What we've also done with our modules is that they carry the relevant approvals and certifications for people like the FCC or the various operators around the world. We also test all our modules for basically any network in the world. We've got more than 6,000 or 7,000 test cases, so you can be sure that your module is not only going to be running here in Stockholm, but if you take it to Brazil or if you take it to Thailand, it's still going to be working there. What's also what we've done is you probably will have the latest smartphone. You'll throw it away after 2 years if it breaks. If you lose it, it's not a big issue. In our markets, if our customers have a problem after 2 years with their technology, it could ruin their business case. So someone has to go out, drive out, fix that, reinstall a smart meter. That's not going to work. There's someone who's putting a module like ours into an expensive piece of, say, farm equipment. The downtime is costing someone money. If our module breaks, he can't monitor that equipment, and that translates to real dollars. And this is why it's important our modules are designed so that you can put them out there in the field for anything up to 15 years. We've added a couple of features to make it more M2M specific. So we've got commands so that you can put the cellular part to sleep or that you can use the power more efficiently. We've even added some jamming detection, a whole lot of features that are more specific to M2M. We've also made automotive grade modules. The Audis, BMWs are very strict with respect to quality. So not only do they have to last 10 years, they have to be able to have all these fancy requirements so that when it goes up to higher temperatures, be it in the desert where you've parked your car, or whether you're going out here out of Stockholm somewhere and it's going down to minus 40 degrees, they want to be sure that those things still work at those temperatures. So, like I said earlier, it's our 10-year anniversary. We've been using and implementing Java for 10 years already. We started off in 2003 with our first generation product where we added Java. And we've been evolving that over the years so that now at the end of 2012, we launched the 5th generation of our product. We've been slowly over time moving up from in the ARM architecture so that the process is becoming more powerful. We started to add more memory over time as well. And now with the latest generation that runs Java ME 3.2 embedded, you're getting a whole lot more functionality. And Marcus will take you through some of that later. So why do we believe that Java is the right approach for our M2M modules, and why do we believe that it's right for embedded? So we think that it fits really well with the architecture that we've implemented in our modules and that we can offer to our customers. So in the past, there was always a microcontroller and the module acting as a sort of a bit pipe. We believe that there's more efficient use of resources when you use one of our Java modules. Also, we see that you can separate some of the deep knowledge that you have to have about what's specific to your particular use case from the cellular technology. So in the past, people had to work with AT commands, low-level programming language. They had to dig down into the cellular stuff and try and understand how to use it. And there were also the people that had to add like an accelerometer, temperature sensor, figure out how the rest of the system works together. So by being able to use Java, we take care of the cellular stuff basically for you. There's a lot of existing experience that you can leverage, and you can focus on what's specific to your vertical. It comes with a complete package with, like I said, a lot of features, J's, R's. It's easy to manage the resources on the module. What's very important, you can remotely manage your application, update it. There's proven tools and developer kits that you can leverage. And was it 9 million developers that you can leverage as well? So what we see is that Java is a future-proof solution. We would love to see broad adoption. We hope that all of you have some great ideas to put into those Java modules. We've got a strong commitment to Java. You've seen that we're already in our 10th year now. Our idea is that in the past, Java was a feature, and in the future, and this is what we've done with the new product, it's actually an inherent feature of all our products, and we're going to be extending that to all of our roadmap. So what we see is, if we look at M2M, and we've been in this industry for soon 20 years, is that it's changing. In the past, it was a point-to-point architecture. Someone would put a device out into the field. It had a single purpose, and it was a fixed setup, one setup, and there was no flexibility over the lifetime. So it was out there for 15 years. This is the case in the Nordics with the metering. Yeah, this is the problem. This is why it's not a smart meter. They did actually use Java in that. But nobody was thinking about future-proofing their solution. And you've got something that sits out there. It collects a single piece of data, and it sends it off to a server, and it does that for 15 years or longer until it breaks down. Doesn't make a lot of sense in today's world, where you're trying to optimize cost, where you're trying to improve your business case, you're coming up with new ideas. So what we believe is that Java has a capability to turn what were very dumb devices into a smart asset that acts as a resource in your company, in your environment. So that you've got a network of data sources, and this is the important point. You've got the flexibility to update and optimize this over the lifetime. So if for our customers, when they develop an M2M or a connected application, they still have to go through a Delta approval. And it depends on the country that they go to, but often they'll have to go through a Delta approval to get this certified. And if you now go and you change the code, chances are you'll have to go back and have it reapproved. If we change the code on our modules, we've got to go through various approvals. This is a huge cost that we have to spread over the modules, or if in case of a specific application, has to be spread across that application. With Java, you get a virtual machine, and you can play around with the code that sits inside this virtual machine. You're not affecting, there's no risk to the approvals, the certifications, and this means that over the lifetime, these 15 years, where in the past you've just been sending one data ping, maybe you want to optimize it because there's a change in the data tariff plan, and you don't want to send every hour, you want to send it only at night. Or you've decided that, I don't know, you can add some logic locally only to send an alarm. In the past, you weren't able to update and manage your application. And now, with Java, this becomes easy, so that you get the data only when you need it, and you only get the data that you really need. So an example could be if you've got a vehicle that's driving around on the street, it's collecting, if you had all the sensor set data collected all the time, you'd have probably a terabyte of data every day. You don't need all this data. You could process it locally, and you only send the alarms across. This is what they do in the Boeings when they fly across the Atlantic, collect a lot of data, send an alarm before they get there to get the people that need to fix whatever's broken there on time, and they collect the rest of the data to analyze later. These are things that you can start playing around with. You have the local logic in the module, in your application to do some pre-processing, and that seamlessly integrates into the backend. So you can have protocols that on Java on the device, you've got Java sitting on the back end, and the way that these interact becomes more seamless. So what I'm showing here is a typical use case, the way people were doing things in the past. So on the one end, you've got the vertical specific sensor input, which is always unique to every application. Depending on whether you've got a security camera attached to it, whether it's a smart meter, or whether you've got a GPS sensor that just detects location. Then you're adding some business rules, some logic to do something with this data that you're collecting. It's being sent over some communication control to a backend, and you're processing that in a database. And in the past, the module was just used as a simple bit pipe. And there were all these resources that weren't really used. When we moved to Java and our modules, you can take out that microcontroller and you can start putting these things on the module and lower your cost. It becomes more efficient in the design, and you can focus purely on that vertical part, that thing that makes your application unique. So that vertical part is often stuff that may be real-time, so maybe you're adding a small, simple microcontroller for the vertical part that collects the data from some sensors, but you no longer need a powerful microprocessor. You can put this application, you can host it on the module, you can have the aggregation, filtering of the data, local business logic, all sitting in there. You can have connection management, so that, say you're going into a roaming scenario, you've got something sitting on a truck that's driving from, I don't know, from Stockholm to Budapest. You don't want to be sending stuff when you're going into, say, the Deutsche Telekom network. You only want to send data when you're an Orange network or Telenor preferred partner. So you can manage that connectivity. You can send, maybe you get a different profile, you want to send the data at night, not during the daytime. All of these are tools that you can make available to control the communication. And then we can add backend clients. So we put together a demo for healthcare, for example, together with Oracle, running the Continua protocol. Continua is an organization that's trying to harmonize and define a standard for healthcare applications. And so once you've got this protocol implemented, it becomes really easy just to connect a Bluetooth, say, blood pressure sensor, a scale, or blood sugar, and that's sent in a compliant format to the back end to be easily processed. So we've called this architecture edge to enterprise. Oracle calls it device to data center. And it's really about optimizing the way that these vertical device-specific elements on a device communicate with the backend. So you can implement these communication protocols. We can have vertical-specific protocols, business logic. These are the alarms that you trigger when certain things happen. You can do configuration and control of your device over the lifetime and update and maintain this not only like in the past once as you set it up, but over the entire lifetime of the application. And with Java, you also you can interact with Java card and some of the secure elements that you can add to your application. Use security features to make your solution more secure. And by doing that, create a smart and flexible solution which you can manage over the entire life cycle of your application. So I brought this because it's all nice you're hearing this from me. And this is actually what a customer of ours said, and I've just copied it. So the feedback we have from our customers, this case is Eclipse from Turkey, implemented a Java solution for metering. They spend the time for the right things, meaning they can focus on their vertical, on their metering specific needs rather than worry about the communication parts. New engineers, they can figure out more easily how to use this Java application. They achieve their results more quickly with less effort. In this case, they had started off with a non-Java solution, pretty quickly moved to a terminal, which has the interface already that was Java in 2006, I think it was. Then moved to one of our modules, and then upgraded to another module. And this means they've been using now in the third or fourth generation the very same Java code that was originally programmed still today. This makes it more efficient. Their competitors, they have to go and reprogram and see every time they start moving to a next generation application. This gives them more room to focus on new things that they want to add. They're able, over the air, to update and manage this, this product of theirs. They can add new features. If there's a bug that they've discovered, they're able to update the software. What we found is that a lot of people focus very much on the hardware cost. What is the price and the bill of materials? In the past, Java was an additional feature. We've now included it in our as basic feature that is inherent to the module. But even when it was an additional feature, paying these extra cents for having the Java functionality paid off over the lifetime, because they were getting this back in terms of being able to do maintenance over the air, being able to add features, being faster to market by being able to reuse their software. And by doing all of this, they feel that their competitors are falling behind them. And this, when you're trying to earn $1 million, is very important. So to summarize, I think the benefits are the reduction in the bill of materials, the more efficient development, the flexibility to go to new architectures, next generation products, the higher flexibility and better management that you get with it. So that said, I want to hand over to my colleague Marcus from our office in Stockholm to take you through some more of the technical details, and then we'll show you a little demo at the end. Yeah. Thanks, Marcus.
Thank you, Axel. Starting with that, I first want to give you an overview about over our module platform, including Java, what interfaces are available, different Java releases, which APIs are available, what we have added to the architecture, and what we offer for the developers support and training. Here you see different modules scaled down. They are based on an ARM11 processor running at up to 520 megahertz with step-down technology to save power if it is not needed. We have memory, RAM, about 6 megabyte available. It's a great advantage. We started in the beginning, or in the second generation, we had 400 kilobyte, but at the very early start with the TCC 45, we had about 600K, 60K, and not so much. The flash file system is nowadays 8 megabyte big, and these different modules are fully scalable. We have 2G and Java, 3G and Java, and 3G with a global footprint. So the differences are not in the hardware so much, it's more in the band selection and if 2G or 3G is available. So you can scale your application, and scaling means also scale the costs. Oops. I'm coming back. So you can scale the cost. Of course, a 2G device is cheaper than a 3G device, and a 3G device with only dual band configuration for Europe is cheaper than a quad band solution with global network access. Interfaces, we have a lot of local interfaces accessible on our module. We have USB interface where we link to the COM connection API from the Java virtual machine. We have serial interfaces which are available as well. I2C and SPI interfaces, also sub-interfaces from the connection interface. We have GPIOs available. You can configure them as output, as input. We have pulse counter functionality. We have digital analog converter, and the other way around, analog digital converters. So you can connect a lot of different sensors directly to the module and get data from these sensors and process them inside the Java virtual machine and transfer it to the backend system. Now to the used Java virtual machine. We use the Oracle Java virtual machine implementation 3.2. It is compatible to the previous modules. So as Axel mentioned before, you don't have to recode or recompile your code to run it. on the current modules. Something new now on the coming generation is that you can use the Java virtual machine in parallel to AT commands on the serial interface. We support multi-threading, and additionally to this multi-threading, also multi-midlet, so you can execute more than one Java application at the same time. The Java virtual machine includes the hotspot implementation. We have security engine inside implemented. We use the newest security engine based on TLS 1.2. So that means you can use it for encryption to support HTTPS and SSL connections. Additional JSRs, you will see it on the next pages. We support remote application update. That means OTAP. We have internet services that you can use higher layer protocols like FTP or mail via AT commands, and of course directly from the Java virtual machine. And beside application update over the air, we're also supporting firmware update over the air. That means you can update the module firmware itself over the air using the internal flash. So now to the new APIs we are supporting. We support the JSR 177 security and trust for SSL. So it supports symmetric and asymmetric ciphering. We have implemented XML parsing and also processing of XML protocol. We support the location API for tracking and tracing. It's very important to calculate distances between two locations, and this is fully supported by that. So building a tracing and tracking application is more or less to connect a GPS receiver to the module, to the serial interface, stream the NMEA data, and processes internal and use this API. We support the JSR 75, the file connection, to get access to the local internal flash file system. Improved security. So Gemalto has a branding also security to be free. So we added and improved the security model inside the module. We have a midlet certification store. With the certification store, you can make sure that only your application signed by your root certificate is able to execute on this module, so that nobody can hack your application and execute a modified midlet, which is maybe providing better data to the backend server that you are lowering your cost. So it really enables you to get control what kind of midlet is executed on the module. We have an application protection. So you can protect the flash file system. And of course, you can use tools like obfuscation to reduce the size of the code and also higher the performance of the Java code. In the new generation, we have a separate certification store for the certificates for the security connection. So that means you can store more than one security certificate in the store and make security connection to different endpoints and servers. This gives a lot of more flexibility. The certification or the ciphering is supported in both directions. The authentication is a client-server authentication. The internet service class HTTPS is also supported. So it's very easy with Java to make an HTTPS connection to a server. The application update in former days, it was only possible via HTTP download. And we now also supporting HTTPS so that you can make sure that the server and the connection downloading the new Java code is secured. The internet services we supporting with our Java virtual machine is the socket service, TCP and UDP, both in server and client architecture. We support chunked mode and transparent mode. And we also have features added like ping service, DNS server, DNS resolver, and we can read out for tracing and tracking. We can offer for debugging. We can read net codes, error codes from the network provider. So that enables you during the development phase and during the lifetime in the field to react on this and make bug fixing. We are supporting an HTTP client, and this client supports also the security connection. SMTP is supported, including attachments, what enables you to send emails with photos or other kind of data. FTP client is included, supporting the passive mode in binary mode, and we also supporting resuming a stream for broken downloads or uploads. Yes, and then I prepared a small demonstration yesterday, which we can do here live.
Yeah, so someone can dial the number.
So it's very easy. It's just.
Have you got a phone?
Yeah, I have a phone. Yeah.
I didn't.
So I should dial that number.
If you dial this number,
yeah.
You can also try to dial it all at the same time to test
exactly.
to test how good all the network. I think, and I hope. So there will be not any cost because the application is rejecting the call and sending back an SMS.
Does it work if I call from an international phone?
Yes.
Oh,
Yeah.
there we go.
I hope so. I hope I have foreseen that.
I hope you have the right number.
Yeah, it's.
So
It'll reject the call, so you won't hear anything.
you will just get back an SMS. I hope so. I just.
You got the SMS? It detected your phone number?
Yes, it did.
Yeah, I hope so. So it is really just to show you how interactive and how fast that is going. And it is not a big deal. This is a code of two classes with a callback function, and it takes me an hour to program that. As background, you should know that since yesterday I'm back from my parental leave, so I didn't have really time to prepare anything. It is really to show you how easy it is working something. Of course, now instead of getting back an SMS, you can upload something to a server. You can do whatever you do. You can just use the incoming call as a trigger to do something interactive.
Okay, we've got a booth up on the top floor. We've got the demo there. You can come and have a look at the demo, try it out, ask us some more questions, and we're happy to answer those, obviously.
So I guess we take a.
Well, I've got one or two slides, so, but not much. The summary, we just to recap, so you get lower BOM, more efficient development. We enable the next generation architectures with this. You get much more flexibility. And what is important, we've got a local presence here in Stockholm. Here's Marcus's contact details. There's some Marcus, the tech guy that I can't speak. We've also got some more colleagues here that are happy to help you. Please contact them or just come and speak to us upstairs on the first floor as well. And we're happy to exchange with you. Happy to talk about ideas. We've got a lot of partners. So if you're a company that is looking for a particular tracking application, we can probably help you there as well. If you're just looking at trying to get started, we're happy to help that as well. So, any questions? Ooh.
So, I don't need a phone. If I want to get started playing with this, how do I do that? What's the easiest way to get started?
To get started.
Like, I need some hardware, right?
Yeah, exactly. So I just take this. We have for each module, we have evaluation or development board. So the module itself is just the module here, but we're also offering a so-called DSB or a starter kit. We have also smaller ones. And with this kit, you can directly power it, connect it to a PC, and start the development. So we offering the whole development environment. You can download it or you can get a CD of that. And then you need this piece of hardware and can start from the scratch. We have documentation, of course. We have the standard API documentation. We have extra documentation like a Java user guide where you see step by step how you get started. Besides that, we're also offering trainings with our distributors. So if a distributor is able to get 5 to 10 customers interested in that, then we will offer them to send somebody there to make a one-day hands-on training that everybody is able to get started and is able to write in a hello world after 3-4 hours to get started and to know how to use our module, how to get the generated code from the PC inside the module, and all these tools are provided for free.
Then maybe just to follow up this, so the first step is obviously the developer kit, and if it's someone who's just trying around, playing around, now wants to make it more marketable and maybe take it to a few customers and test the idea, next step is probably to go to a terminal.
Yep.
So in the case of a terminal, the module sits inside a nice plastic housing with a couple of interfaces. It looks a little bit more professional. And we've got customers, actually Konica Minolta's connected copier machines doing that. They've done more than 100,000 using our terminals. So you might wonder why they would use a terminal to a big copier machine that's sitting on a network. Sometimes there's a firewall. It's not so easy if you're Konica Minolta wanting to offer a service so that you can see when the toner is running low. You don't want to go through the customer's intranet. And then the next, obviously, but 100,000 is probably a bit much on the terminals. We like it, it's good business, but typically if you're doing a couple of thousand, you would then move to the type of module that you solder into an application you do a specific design for. It becomes more cost competitive and it scales better. And the beauty with Java,
Yeah.
you can port the code from one solution to the next and without having to make any adjustments.
Where do I buy that?
Come speak to us.
Contact us. We can help with that. We have in each country we have distributors, and of course we have direct sales. So you can, in any case, contact us directly. If for buying this is Patrick Larsen and Magnus Ahl. They are both sales guys. So just drop them an email, and we will make sure that you get.
Right. And the cell phone connections, I just use a normal SIM card for that?
Yeah, quite normal SIM card. Here on this board, for example, you have two slots for SIM cards, and you can take the SIM card from your phone. So
We can put it in there.
if you put your your SIM card inside here, everybody can call you and get an SMS back from you. No, it's quite usual. It's nothing special.
Yeah, I'll put my US SIM card in there and I'll make AT&T very happy with it.
No,
It's just SMSs.
So it's this development kit should make it as easy as possible to get started and not make things complicated. So it's standard stuff, standard serial interfaces, standard mini USB connector. You can even power the whole device. You don't need a power supply. It's powered by the USB connection. So a power supply is not needed, can be extended. So we try to make it as simple as possible.
Sorry, I wasn't really clear with the questions and answers. So I don't belong to a big company. If I just want to play around with something like this, do I have to pay for it? Do I have to call you guys and get one, or will you send a free developer?
So, yeah, it's not free yet. We're looking at, there'll probably be various programs over the year where we try and maybe make something available. We're looking at Oracle to work together with the local Java user group. It's not, the dev kit, the old generation was probably around 200 euros, where we had these trainings, or you paid 200 euro for the training and you got the kit. With the newer generation, we're going to try and make that more cost competitive. But you get the entire developer environment, everything included in that. And like I said, over the year, we'll try and make it more cost competitive as well.
And talking here from the local office, I just can say, contact the sales guys always, because of course, if there is a potential behind, in practice, we have also very often say, we give you a dev kit for 3 months, we land it for 3 months, play around with that, then we contact you again, what is the outcome? We just want to prevent that we just shipping a dev kit because it's for free, then it's not used at all. We want to make sure that it is used, and if we see a potential behind that, we are quite flexible, so just
and I'm a marketing guy, so if we can make a nice story out of it.
If we get back a demo from this experience from your programming, maybe then you get it for free.
So in the US, you already have a partnership with AT&T, where you basically go in on their website and you just order one online and you get it sent to your home. You pay with your credit card, I know, like a couple $100 or something. Are you doing something similar in Europe?
We've got a similar thing with Deutsche Telekom in Germany. I'm not sure whether we're doing anything with Telenor.
I don't know here. Very often it's like this. These contacts, you can also get them on the website, and it's all about contact our local office, talk to them, and if there is an idea or if they see that there is something behind, very often we don't want to earn money with a development kit. We want to earn later on money with the volume selling modules and not the dev kit. But on the other side, the dev kit has also cost something to us. But I think a good idea is then to just lend it out for a while.
Looks like Telly has a partnership with you guys. Maybe you can buy it from them.
Yeah, I guess we don't do that. Well, I have 2 nasty questions. How does the power consumption compare to other competitive products, and the pricing model, of course? Like, obviously, if we want to sell like 1 million pieces, I don't really care if the programmer takes like 2 hours or 3 hours, because it won't matter at the end when I price. Of course, I like Java. We all like it here, and we understand that it's easier to develop for Java, but at the end, it's just a business. I mean, can you say something?
You'll get a good price for 1 million pieces. Don't worry.
To the power consumption, the power consumption is more or less related to the radio part. And very often, if the Java virtual machine is doing something, of course, you are transmitting data, and then the power consumption is done by the radio part. I once made tests just using the module in idle mode without doing any Java, and then used internal mass calculations and really stress the processor only with calculation power without transmitting something over interfaces. And then the Java virtual machine really going to the border of power, it takes 5 to 6 milliamps. But if you see during transmission mode in UMTS, you easily use 800 or 900 milliamps in the peak. Then the 6 milliamps for the Java virtual machine is really, really low. So if you program, this is the extreme level in one side. If you're now going to the other side, is if the module is using Java and you have running Java, but all threads are not active, so you're just using, you are having callback methods waiting for some incoming events, then the power consumption is 500 microamps more than without Java. So it's all about using how much transmission is used.
And basically, it's like you'll have some experience with your mobile phone. So in the days when you didn't have a fancy screen, it used less power. These applications typically don't have a big, bright colored display. And it depends on how much you're moving as well. If it's just lying on a desk or it's fixed installation, if it's driving around from one cell to another.
Do you have real-world applications when you use it purely mobile version? It's not connected to like cars.
You think of it, most of our customers have done something similar like it. So if you've got a local application that's really mobile, Without
for tracing and tracking, we have for animal tracking and for
Container
people
tracking.
so container tracking, and you have this kind of badges or mobile things that you can be tracked where you are. Or in Finland, it is quite often used for hunting, that you can see where are your dogs. They have all such you can see where are the dogs if you're hunting the moose. So this is quite common. So we have mobile tracking applications.
Yeah, we've got, which I think is a more powerful device. There's a customer in the US that did a heart arrhythmia detection. So it's basically like a mobile ECG. It's the size of a smartphone. It's got a small black and white display, I think, or just a few colors. And the idea is that the patient can carry this around for a month to track the heartbeat. And when there's an abnormality, it'll send that data with a special code encoded over to the doctor so that the doctor can contact the patient. And the idea is that he doesn't have to recharge it for a month. And earlier this morning was an example of the tree tracking, the device sitting in the tree for more than a year, hidden away so you can't see it, running on a battery supply. Obviously there it's not very, it's stationary. It's when it starts moving that it becomes active. So, yeah, many solutions, many possibilities. More questions?
Okay, I have one. This would be great if we could add this kind of Arduino shield pins, because this would be a much nicer platform than the Arduino, I think, because then we have Java and we have instant connectivity. So have you considered adding those pins so we could use all these hundreds of shields with sensors? And
So we're working on an Arduino type of solution as a dev kit. Should be available sometime middle of the year. And I think, Marcus, I don't know, you can probably add something there.
Yeah, as presented, you have a lot of interfaces where you can do something adapting to other platforms. So it could be a future idea, yes, of course.
You're not the first one who asked that question.
no, it's really, it would be a great platform. Yes. It would be.
Yeah, we agree.
Okay, so
if you're shy and don't want to ask questions now, come and see us up later. If you think of any other question to ask, come and see us.
Yeah, you're up on the balcony.
Yeah.
Yeah.
Okay, thank you.
Thank you.